Okay, so picking up right where we left off, we had created one puzzle piece and two sockets to demonstrate that a puzzle piece will only fit into the socket of the corresponding name, and that is done intentionally. That way a single line of code simply checks to see if the socket and the piece match, and if so, then the piece gets relocated into the location of the socket. That way the puzzle pieces line up correctly. Now, before we go any further, I'd like to add a particle system, and the reason for that is that you don't just want the puzzle piece to snap in. A lot of games do that, but I'd kind of like to add a little bit of a visual flourish. That way it gives a little bit more feedback to the player, like, yes, you accomplished this, this is where it belongs. So what we're going to do is we're going to create a particle system. Technically it's going to be 4 particle systems, one for each border, which lights up when the puzzle piece fits in. So I'm going to quickly create a particle system. I'm not going to go through all the details. You will see all the settings, but I'm not going to explain everything because that alone would take quite some time. And if you have to just pause the video to see what the settings are. So game object particle system, shape, edge, rotate it to 0 for rotation. Start lifetime should be 1. Start size should be 0.35. Start speed should be 0.1. Emission, bring that up to like 400. Max particle, bring that up to 1500 just to be safe, but shouldn't be an issue. Size over lifetime, click there, add a key towards the end, doesn't matter exactly where, and then move the final dot down towards the bottom. Again, doesn't matter exactly where. The gist is that you just want the particle to sharply drop off in size. That way it just doesn't disappear from its full size, it actually shrinks. Then do the same thing for color. So color over lifetime, click there, add a keyframe towards the end. That way there's no change through most of its life. And then on the bottom of the end here, click on this marker and drop it all the way, maybe not quite to 0, but really close. Now, that really doesn't show up like much of anything yet, because it's probably not moving fast enough. So let's have that start lifetime drop down to 0.5, but let's bring the start speed up to 0.5. So it's probably a little bit too much, part 0.4. Okay. Now, let's line this up with the puzzle piece so we can see how wide it should be. Just stretch it out. Now, when you're scaling the size of a particle system, you may wind up having to change particle size and particle emission, because since you're increasing the area, it might not look right anymore. So keep that in mind when you start scaling an object, a particle system, excuse me. Still doesn't look quite right, so let's have start speed go down to 0.3, but start lifetime be more like 0.7. There we go. Now we will change the duration down to 0.4, and we get rid of looping. So it wasn't going to look right anyways because it kept looping, but you really need the looping when you're building it. So let's run it. There we go. So you kind of have this border that appears and pushes out. Now we're just going to, let's call this top border. Now we'll copy that and paste it. Move that down. And then we rotate that one 180. And let's run it to make sure it looks right. But should, because the Y arrow, rather than pointing up, is now pointing down. Good. rename this one bottom border. Now we'll copy this one again, paste it, call this left border. Suppose I could have done edge, that probably would have been easier to type, but whatever. And for this case we want to rotate not sure if it's the Y or the Z, sorry, we'll find out really quickly. I think that's right though, because now the Y-axis is rotated 180. Nope. So let's try the Z-axis, 180. Nope, still wrong. Gonna have to do it manually. Probably actually rotating 2 axes to make it work, right? Alright, so it looks like it rotated. Oh, I know, I was doing 180. Should have only been 90 because it's perpendicular. Sorry. So when I went from the top to the bottom, it has to rotate 180 because they're parallel. This one's perpendicular, so you only want it to rotate 90. So the Z is the proper one to rotate. It just only had to rotate 90. So sorry about that. So now it's too big because it was originally scaled for the size of the top edge. Okay, so that looked pretty decent. You can shrink it a little bit more. Looks good. And now we copy that. We'll name it right border. And that one should be rotated negative 90, I believe. Yes. Okay, so now we select all 4, and it actually won't let me run it like that, so we'll just run it. There we go. So that looks good. So what we do is we need to create one object out of this. So it really doesn't matter which one you want to use, but one of these has to be the parent and the other one has to be children. That way when you position one, all the other ones get positioned as well. Or if you want to, you can create a 5th object and attach all 5 to it. Might be a little bit easier to position it like that. So let's actually do that. So let's take this puzzle piece because we know it's the right size. We'll copy, we'll paste, and we'll just call this edge glow. We will remove the rigid body, we'll remove the box collider, and we'll remove the script. In other words, I just wanted something that was the right size. We also get rid of, before we get rid of the puzzle piece, let's now attach all 4 of these just by dragging and dropping them onto edge glow. And now for edge glow we will also get rid of the dorm piece. We'll do none. Now it should work. Perfect. So what we want to do is take that edge glow, drag and drop it into the asset area, turning it into a prefab, and now delete the object from the scene. So we did all that so that we can now instantiate this when the piece is placed. So let's go back to our script, and again, move piece is the script that's attached to the puzzle pieces. We need to make it aware of this prefab. So public transform, capital T, edge particles. We save it, and now we go back to our puzzle piece, and there's the edge particles. We just drag and drop it, and we put it there. And now, so on trigger enter 2D is where the puzzle piece gets locked into place. So that's what we want to do. We want it to instantiate the glow here. So instantiate edge particles. Where we want it to instantiate, we'll use that same location. Other dot game object dot transform dot position. So even though it doesn't look like coordinates, because as I've said before, the three arguments are what's being instantiated, where it's being instantiated, and the rotation of what's being instantiated, this doesn't look like coordinates, but it is, because as we've said before, this, when you use this format, transform.position, this inherently is storing either vector 2 or vector 3 coordinates. And then we go back to edge particles dot rotation. Because if you recall, we did a bunch of rotations. If we don't use those rotations, it won't look right. So watch what happens. So moving our piece around, and as we said over here, it won't lock into place because that's the wrong socket. But when we get to the right socket, not only does it lock in place, but now you've got that little glow briefly to indicate that it has been fixed into place. And considering how little effort it took, it's a nice little flourish. It's a nice little touch. Gives feedback to the player. You could also have a sound, and it would just be public. It would be a sound variable. I'd have to double check to see exactly how to do it. And then just as you instantiate the particle system here, you'd have a separate command that says, okay, play the sound. That's how you could also do that. So basically everything that you want to happen when you lock in a puzzle piece, you would have it lock in here. Like if their score increases, then you'd also have the score increase here. Okay, so now, what else do we want? Say we want to, well, I was going to say we want to penalize them if they put it in the wrong place. I suppose we could do that right now. We really want to wait for the click, but for the moment, we'll do that. So, what we're going to check for is public key code we'll call it place piece. So it's a key code. It's going to look for some kind of input. So place piece, what you're going to do, scroll way down, get past all the keyboard, and you can actually get all the way to, it's looking for mouse. Mouse 0 is the left button. So now, the program is now looking for a key press of the mouse. So what we have to do now is this kind of situation really needs to change, because we said, okay, as soon as there's a collision, we want this to happen. Well, we want to also make sure that the mouse has been clicked. In void update, if input dot get key down, we only want to check for a single mouse click. We'll call this place piece. So if that happens, we need a new variable. Public int, actually let's do a public string. Public string check placement. So check placement is now set to Y for yes. So we look for the key code, which is set to the mouse. If that key is pressed, then this variable is set to yes. So now what we want to do is we need to actually change it. This was changing it for enter. Now we want it to be stay, because we want to check every single frame that they are that the two are colliding, and not just as soon as they overlap. So on trigger stay 2D, we still want to check for that, but we also now want to check to see if the mouse has actually been pressed, and we do that by seeing if check placement equals yes. So we look to see if the when a collision is occurring, we look to see if the names are matching, and if check placement has been set to yes, which only happens when there's a mouse click. So effectively you're checking for a mouse click. If so, go ahead and do all this that we already set to do, but change check placement to no, because we don't want this to be spammed. In other words, the reason why this was working is because there's on trigger enter, which is only the single frame in which the two objects overlap. Now that we've changed it to stay, it would spam these over and over again unless we set this to no. So that should actually do it. So right here is where our socket is. And I once again forgot an equal sign. Sorry, that's probably really aggravating to you guys, because I do it like 99% of the time now. I guess it's good to see the errors occasionally, because eventually they will happen to you too. So before, just placing it over it, it would fall into place. You may want that mechanism for a game. We don't, because someone could just take a piece, scroll over the whole thing, and it falls into place. Now you have to actively say, this is where I think it goes. Boom, and it falls into place. So now there's an awful lot of forgiveness because of the size of this square, or should I say the size of the collider, and the size of the collider on this. So what you can do is you could actually shrink these if you want it to be not quite so forgiving. Because if you look at it, you could actually be off by that amount and even a little bit more, and it'll still fit it into the right place. So this would be game balance. You know, how much do you want to tweak it to make it a little bit more challenging to the player? That's 100% your decision. I'm not going to sit and do that, because you could do that for hours. Because like I said, this is the primary function that you're doing this game, is the placement. So you really want to give a lot of care to how challenging you want the placement to be. But now that we've done that, and that was big, because now you actually have to actively say check if it's the right place rather than it just automatically checking for you. Now we can penalize you. So this is looking to see if the object, so there's been a collision, okay, and it's looking to see if the names match and if the button has been clicked. So what you can do is you can do a separate one that checks to see if the names don't match and there's been a click. Might be able to do that with an else, but let's just type it out for now, because as far as I'm concerned, you can always optimize the code at a later date. Usually, the first code you write tends to be a little bit bloated because you just want to make it work. Then you can go back and optimize. But once again, with these 2D games, optimization of code really isn't a big deal because they're not resource intensive. Okay, so what we want to do, we said, is we want to check to see if you've clicked the mouse, but the names don't match. So, again, a collision is occurring. The names do not match, so the puzzle piece does not match the socket, but you did indeed click. Then what we want to do is we want to penalize you, and we're going to penalize you by making the piece slightly transparent. And that's really easy. So get component, and it's going to be sprite renderer dot color equals new color. Now we're not changing the red, green, or blue, so we want those to be 100%, but we're changing the alpha. Now to do this right, we really want this to be a variable, but just for you to get the idea to see how it's working, we're going to put in a constant, so 0.5f. Make sure you put in that f. When you're using vectors, or in this case RGB and A for alpha, you still have to put in that letter F when you're using a decimal. So let's go ahead and save that. Because what happens is if you get it wrong, it reduces the transparency by half. If you get it wrong again, it doesn't change the transparency anymore. So what we want to do is we want to have this actually be a variable, so it gets less and less visible. It becomes more and more transparent, but once you place it, we want the transparency to be 100%. So actually, let's go ahead and put that in, since that's an easy fix. So if we didn't do this, it would stay partially translucent when it goes into the right place. So here we go. We run it, and I believe it's right around here. There we go. See how it's only translucent? But now we put... you know I did wrong? This has to be here too, sorry. So once a condition in the trigger area has been true, you really want to reset that, or else it thinks the mouse has been clicked again. So the socket is over to the right here. So just going over it, passing over it doesn't do anything, but if I click, it becomes translucent. And see, now it didn't automatically jump over like last time. And now when I click, it's in the right place, and it is now solid again instead of being translucent. It's a little hard to tell the translucence because it's a solid blue background, but it is working, I can tell.